Today, we're peeling back the layers on something utterly fundamental to textile engineering, something you use every day, yet, well, never actually see. Seam allowance.
It really is. It's the definition of invisible engineering in the apparel world, isn't it? People think about fit, about drape, but seam allowance? That's the quiet precision. It's the hidden detail that decides if that expensive jacket lasts years or, fails after one cleaning.
Exactly.
So our mission today is to get past the basics, the sort of home sewing ideas, and really dive deep into the technical foundations, the industrial standards, basically how the pros handle every millimeter in real production.
I like that moving beyond the basics. We're looking at this not just as a measurement, but as a strategic element.
Mm.
Okay, so let's nail down the definition for anyone maybe newer to this side of things. What exactly is seam allowance?
Right. So at its core, seam allowance is simply the distance between two key lines on any pattern piece. You've got the stitch line, that's what defines the final shape and fit, and then you have the raw edge of the fabric. It is that extra bit, that margin beyond the stitch line. It's essential for actually joining the pieces together physically. Without it, there's nowhere to put the stitches without compromising the garment's shape.
Okay, precision. Let's unpack that. What are the sort of standard go-to widths used in industry? Are there common numbers?
Yeah, there are definitely common widths you see again and again, mostly for efficiency. Things like 7 millimeters, which is about a quarter inch. Then you see 12 millimeters, half an inch, and 15 millimeters, or 5/8. These often line up with standard sewing machine presser feet or guides. Makes things quicker.
But you mentioned earlier, it's not one size fits all. The professional approach is dynamic.
Yeah.
So what forces a pattern maker or a technical designer to say, okay, forget 12 millimeter, we need something different here? You mentioned three key variables.
That's right. The width absolutely has to be tailored. We generally group the influencing factors into three main categories: the type of seam being constructed, the behavior of the fabric itself, and the specific area on the garment.
Let's take seam type first. Why is the structure of the seam the biggest factor? Wouldn't the fabric itself be more critical?
It's a fair question, but the structure is usually primary because different seams physically consume different amounts of fabric to be constructed properly. Think about a really common seam, like a standard surged or overlocked edge finish.
Right, quick and simple.
That might only need, say, 12 millimeters of allowance. But contrast that with something like a French seam. With a French seam, you're folding the raw edge inside the seam itself, enclosing it completely. It's a beautiful finish, but
It uses more fabric.
a lot more. You absolutely must start with a wider allowance, maybe 15 millimeters, maybe even more, because the structure itself is designed to fold and enclose that fabric. If you try to make a French seam with only 7 millimeters, well, you wouldn't have enough fabric to make the second fold. The seam would just fall apart. It's a structural necessity.
Okay, that makes perfect sense. So, variable two. Fabric behavior. This is where the material science comes in. Right?
Exactly. This is where we deal with let's call it the personality of the fabric. Think about something really delicate, like a silk charmeuse, or maybe a loosely woven linen. They fray like crazy, they shift around.
Nightmare to handle sometimes.
Totally. So for those, you need a larger allowance, maybe 15 millimeters again. You need that extra margin as a safety net. It ensures that even with handling and stitching, the fabric doesn't just disintegrate or pull away from the stitch line before the seam is properly secured. Now, flip side. A really stable, tightly woven cotton twill or a heavy canvas. It doesn't fray much, doesn't stretch or shift.
Much more predictable.
Right, so you can often get away with a much smaller allowance, maybe 7 or 10 millimeters. The material itself is reliable. And then you have specialized cases, like technical fabrics for outerwear that might be coated, or materials that need heat bonding. They need very specific, often non-standard allowances dictated by the bonding process or the machinery.
Fascinating. Okay, variable three. Garment area. Why does where the seam is on the body affect the width?
This is all about balancing strength with aesthetics and comfort, specifically managing bulk. In areas with tight curves, think necklines, armholes, collars, or places with lots of detail, like darts, we actually need narrower allowances, sometimes as small as 5 millimeters.
Now that feels counterintuitive. Armholes seem like high-stress areas. Wouldn't making the allowance smaller there make the seam weaker?
It's a classic engineering trade-off. You're right, wider usually means stronger in raw terms, but in those tight curves, if you have a wide allowance, say 15 millimeter,
All that extra fabric gets bunched up when you turn and press it.
Exactly. It creates horrible, unsightly bulk, it makes the area stiff, you can see ridges, and it prevents the curve from sitting smoothly against the body. So, in those zones, reducing bulk for a clean finish and smooth drape often takes priority over maximizing raw strength, assuming you use a strong enough stitch type, of course. We minimize the allowance to get that smooth curve.
That's a great example of balancing conflicting needs in design. So where do we typically allow for wider allowances then?
We usually afford wider margins, maybe 15, even 20 millimeters, in areas that are generally straight, low bulk, maybe high stress, or importantly, areas likely to need alterations. Think side seams, center back seams, sometimes inseams or crotch seams in trousers.
For alterations, makes sense.
Yeah, that extra width provides reinforcement, sure, but critically, it leaves room for tailoring or fit adjustments later on. That's really key for bespoke or higher-end garments. And of course, hems are almost always wider than construction seams. They need that extra width and weight for a clean finish and good drape.
Okay, this complexity perfectly sets up the next stage. How does industry manage all this variation? 7 millimeter here, 15 millimeter there, 5 millimeter up top across thousands, maybe millions of pattern pieces. It can't just be someone with a ruler and pencil.
Absolutely not. No way. This is where industrial pattern making using sophisticated CAD/CAM software is just indispensable. And the really crucial concept here, something fundamental to professional practice, is that the seam allowance isn't drawn directly onto the base pattern. It's managed as a completely separate digital layer.
Just separate layer. Why is that separation so vital? Why not just bake it into the pattern from the start?
Well, think about it. If the essay was permanently fused to the base pattern, any change you needed to make to the allowance, maybe for a different fabric or different seam type, would mean redrawing the entire pattern piece.
Which risks messing up the core fit, the actual shape of the garment.
Precisely. The core pattern piece, the line that dictates how the garment fits the body, stays untouched, pristine.
Okay, and what does that separation unlock for the production team? What are the big advantages?
Oh, several huge ones. Four main benefits come to mind immediately. First, zone-specific variations become effortless. You just tell the system, okay, all side seams get 1.5 centimeter, but necklines get 0.5 centimeters. The software applies it instantly and accurately across every single piece in the pattern set.
Right, solving that bulk issue we talked about automatically.
Exactly. Second, it allows for easy seam sequence adjustments. Let's say the factory changes the order they assemble the garment. Maybe they decide to set the sleeve in before sewing the side seam instead of after.
The required overlap might change slightly at the junctions.
Precisely. The layer can be instantly modified to reflect the correct allowance needed for that new assembly order without touching the base pattern fit. Third, and this is massive, size grading. When you scale the pattern up or down for different sizes, small, medium, large, etc., the system scales the base fit lines correctly.
But it keeps the seam allowance consistent.
Yes. It maintains the correct width needed for the sewing construction, regardless of the garment size. If it just scaled everything proportionally, a size XXL might end up with a ridiculously huge, unusable seam allowance. This separation prevents that.
So scaling the fit doesn't break the manufacturing requirement.
Got it.
And the fourth?
Automation and consistency. Separating makes the data clean and ready for automated cutting machines. This ensures every single piece of fabric cut has the exact same perfectly consistent seam allowance. That's absolutely critical for quality control later on.
Okay, so that's the ideal scenario. But let's shift to the real world because, well, things go wrong. What happens when precision is lost? Maybe a factory is cutting corners, trying to save fabric, or just makes calculation errors?
Yeah, unfortunately it happens. And when that precision fails, garment quality and durability plummet. We generally see three main risks, three failure modes. Let's start with risk number one, seam allowance that is too narrow.
Okay, intuitively that sounds bad. Why is cutting it too close to the stitch line such a problem?
The fundamental issue is that the stitches end up landing too close to that raw fabric edge. If you only leave, say, 3 millimeters of fabric beyond the stitch line on a material that frays easily, well, there's just not enough material for the stitches to securely bite into.
The seam has no integrity.
Exactly. It leads to immediate fragility. You massively increase the risk of the fabric fraying right up to or even past the stitch line. Or you get something called seam slippage, where the fabric threads literally pull out from under the stitches when any tension is applied. The garment might look okay initially, but after a few wears, maybe one wash cycle, pop, the seam just gives way.
So it dramatically cuts down the lifespan and strength of the product.
Absolutely. Now, flip to the other extreme. Risk number two. Excessively wide seam allowance. You might think, more fabric, safer, right? But no, that causes its own set of problems, mostly aesthetic and comfort related.
Right, we touched on bulk earlier. If you have too much fabric flapping around inside the seam, what does that feel like to the wearer?
It creates stiffness and thickness where you really don't want it. This is especially bad in tailored garments where you want clean lines, or critically, in anything worn next to the skin, base layers, underwear, shirts. That extra bulky fabric inside the seam acts like a ridge. It can show through as visible wrinkles or lines on the outside of the garment, distorting the silhouette, and it can be really uncomfortable, leading to chafing. If you've ever worn a shirt where the collar stand feels weirdly stiff or the armhole seam digs in, often that's down to an unnecessarily wide essay creating internal bulk.
Okay, that makes sense. Which brings us to risk number 3, which sounds maybe the trickiest. Inconsistent seam allowance along the same seam. So it starts wide and gets narrow, or vice versa.
Yeah, this one is insidious because it's not about the overall amount being wrong, but the consistency. If the allowance varies along the edge, maybe it's 15 millimeters at one end and drifts down to 10 millimeters at the other, imagine the poor sewing operator trying to join that edge to another, hopefully consistent edge.
It's like trying to zip up two sides of a zipper where the teeth don't line up properly.
That's a great analogy. Something has to give. You're forcing two uneven lengths together. The fabric inevitably gets pushed around. It might unintentionally ease or gather in places, or the whole seam might start to twist as the operator tries to compensate. The result: you get panel distortion. Seams don't meet correctly at corners. The whole garment panel can end up slightly warped.
Okay, so the stakes are clearly high. What are the practical ways manufacturers prevent these issues? What are the key mitigation strategies?
It really boils down to layers of verification throughout the process. It's not just about getting the design right initially. First, as we discussed, relying heavily on those automated validation checks within the CAD software, catching deviations early. The system flags anything outside a set tolerance, maybe even zero point 0.1 millimeters on critical curves.
Using the tech to police the design before cutting.
Precisely. Second, the tech pack, the master document for production, has to be incredibly clear and specific.
Clarity is key.
Absolutely. And third, you implement mandatory physical testing. This means taking samples from batches and doing actual seam strength tests, pull tests, wash tests. This validates it performs as expected under stress before you commit to mass production.
So, multiple checks and balances. Bringing it all together then, we started with this tiny hidden measurement. And it seems like it dictates almost everything from digital design right through to quality control and the final product's life.
That's really the core takeaway. Seam allowance isn't just a minor cutting instruction. It's a strategic, carefully engineered component. The precision, or lack thereof, in setting and executing those allowances directly impacts strength, fit, comfort, aesthetics, basically the entire perceived quality and longevity of the garment. It echoes through the whole production chain.
And the message for you, our listener, is really about appreciating that precision. That dedication to getting the details right, even the ones hidden from view, is fundamentally what separates high-quality, durable clothing from something disposable. It's like a silent promise from the maker to the wearer. Thanks for joining us. We'll see you next time on The Deep Dive.